Okay, so the next thing we're doing is working out whether a particular number is in a sequence. Okay, so to be able to do this, you do need to be able to work out the nth term of a sequence. So if you've not done that, you need to do that first. Okay, so I've written a few questions here. Now these sorts of questions are generally with other sorts of questions with it. So generally they'll be with find the nth term, which is why I've done it for here, or find the 50th term in the sequence, things like that. So it's normally part of a big question, not generally on its own. The first thing you'll be given is a sequence. So we're given 5, 7, 9 and 11. So part A is we just need to find the nth term. Okay, so find the nth term, we see what we need to add on to get to the next number in the sequence. So to get from 5 to 7 and then 7 to 9 and then 9 to 11 means we're adding 2 each time. Okay, so that's the number we put in front of the n, it'll be 2n. Okay, then we need to find the 0 term, or the one that would have appeared before the 5. So at the moment we've been adding 2, we need to do the opposite, so we'd have to subtract 2. So 5 subtract 2 would give us positive 3. So it's going to be plus 3 there. Okay, so that's part A done. Part B is the new bit. Now the easiest way to do this is to do equations, okay? So you've got to make sure that you know how to solve equations. The reason why we're going to do that is, what we're going to do is we're going to set the nth term equal to the number that we're looking for, and if the n is a whole number, it will tell us which term it will be in the sequence. If it ends up not being a whole number, the n value, then it isn't in the sequence, okay? Because all these have to be whole numbers, because this is the first term, second term, third term, fourth term, etc. Okay, you can't have a 6.5 term, it doesn't exist. Okay, so for the first one, we want to see whether 33 is in the sequence. Okay, so I've made the nth term equal to the number that we're looking at. Okay, so to solve it, we want to eventually get n to be on its own. At the moment, it's being multiplied by 2, and you've got this plus 3 here, so I'm going to subtract 3 from both sides. Okay, so then I'll be left with just the 2n on the left, and then 30 here. Okay, again, I just want 1n, I don't want 2n, so I'm going to divide by 2. So that tells me that n is equal to 15. So this is telling me that 33 is the 15th term in the sequence. Okay, so it's ended up being a whole number or an integer if we're being posh. So that tells us which number in the sequence it is. Okay, so the next one we're going to do exactly the same way. Okay, the only difference is that the number that we'll be having here will be different because it's a different number in the question. Okay, so I'm going to do the same working, so subtract 3. So I'm left with 2n again on the left and 49 here. Divide both sides by 2 to give us just 1n. Which is 24.5. Okay, so now because n is a 0.5 number, or just any decimal, 52 cannot be in the sequence. So 52 is not in the sequence. Okay, that's all you have to do. And it's the same workings for every sorts of questions that you'll get. You'll always do the same thing. Okay, I'm going to do another one. Okay, I thought I'd add some more negative numbers in because I know quite a few people don't like negatives, but we just have to get on with it. Okay, so for this one, it doesn't ask us to find the nth term in the questions A and B, but to be able to do what we've just done, we do need the nth term. So that's the first thing I'm going to do. So the nth term. Okay, so the first thing we do is how are we getting from 12 to 5, 5 to negative 2, and so on. So I must be taking away 7. So it's going to be negative 7n. Then we've got to find the one before it. So we need to be adding 7 because that's the opposite of what we have been doing, which gives us positive 19. So the nth term would be negative 7 plus 19. Okay, so for the next bits, the actual answering of the question. So we write the nth term and make it equal to the number that we're looking at, which is negative 23. Okay, now there are different ways of solving this. I'm just going to do it the same way as what we did the other one. I'm going to deal with the number that's on its own. So we've got this plus 19, so I'm going to subtract it from both sides. Now be careful with your negative numbers. So this will still be negative 7n. Negative 23, take 19 more away, would be negative 42. Okay, then we divide by negative 7 because we just want one positive n, we don't want negative n. Okay, so a negative number divided by a negative number would give us a positive number, and the number of 7s that go into 42 would be 6. So negative 23 is the 6th term in the sequence. Okay, again, part B, exactly the same method. Okay, it's just I've changed that number at the end because that's the number in the question. Subtract 19. Okay, now you can use a calculator for this bit if you really want to. But if you think about your 7 times table, the number closest to 71 would be 70, because 7 times 10. So we know that 7 won't go into negative 71 perfectly. Okay, so you could leave it as a fraction if you wanted. Or you can write it as a decimal. 1/4, yes, it'd be 1.428 something. Okay, so again, it's a decimal, so negative 52 is not in the sequence. Okay, because it's a decimal answer. Okay, so that's all you have to do. It's not too bad as long as you do the same method every single time. So nth term equals the number that you're trying to work out is in the sequence or not. Solve it, and if it's a whole number, then it is, and it will tell you which one it is. So because it's equal to 6, it's the 6th term in the sequence. If it doesn't equal a whole number, it equals a decimal instead, then it definitely is not in the sequence.